So the most important forces of circular motion is the centripetal force, which in Chinese we call 向心力, towards the hard force, a force that is acting towards the center.
Here we have a short summary of the aspects of uniform circular motion. First, it has a constant speed, yet it has a varying velocity. And it also has a resultant acceleration that's always pointed towards the center, and as you can see from the centripetal force, that's always pointed towards the center. Finally, we have the four mathematical models of uniform circular motion. First, we have angular velocity, which is easily the rate of change of angular displacement over time, and can be expressed as 2 pi radians over time. Next, we have linear velocity. This is basically the rate of change of circumference over time, which is 2 pi r over t, and you can simplify it as r omega. Next, we have centripetal acceleration, which is r omega squared or v squared over r. Finally, by multiplying mass, you get the centripetal force.
This setup is made out of 2 bottles, one with liquid and one empty, connected by an inextensible string with a smooth point of contact in between. At equilibrium position, M1 will pull M2 down. M1 stays in position when he resets his hand. Taking outwards to be positive, the resultant force will be equals to weight plus tension 1 minus tension 2. At equilibrium, tension 1 equals to tension 2, therefore centripetal force equals to weight. And now we'll proceed to find out the velocity required to keep M1 suspended. Through our calculations, the velocity is 4.27 meters per second.
This example can be seen when cars turn on the road. Hop on.
One aspect of the law of inertia: objects at rest tend to stay at rest. Passengers in the car are at rest. As the car starts to drift, passengers will feel as if a force is acting on them in a direction normal to the direction of the drift. The feeling of being thrown sideways is merely the tendency of your body to resist the change in velocity and to remain in the state of rest. This fake force is known as centrifugal force.
In the next experiment, we'll be using one styrofoam board and 3 cups of water. We'll be swinging it in a vertical circular motion to see if the cups will fall off. By Newton's first law, the cups will tend to move in a straight line, but the normal force of the board will create a centripetal acceleration that will keep the cups moving in a circular motion in contact with the board. The water does not fall on our heads because it is moving tangentially to the circular path faster than it is moving downwards due to gravity. Gravity pulls it down by a rate that is matching the tangential speed. Hence, the weight, allowing the water to move in a circle, is the main component of the actual centripetal force. Since angular velocity is assumed to be constant, the centripetal force will be the same throughout. If the speed is larger than the critical speed, the contact force of the bottom of the bucket, pointing towards the center, helps the water stay in a circular path.
A real life example is yo-yos.
To start the yo-yo, a circular force is produced from the hand. When the string contacts the finger, it becomes taut. The tension will cause a centripetal acceleration that enables the yo-yo to travel in a circular path.